Hi, so let's talk about prime factorization. By definition, it's simply a process of expressing a whole number as a product of prime numbers. So in short, we're going to rewrite a whole number whose factors are all prime numbers. Now let's talk about the prime number. Prime number are simply the numbers whose factors are just 1 and itself. As you can see here, we have the basic examples. The first three prime numbers that we have on the list. We have 2, 3, 5, but there are a lot more of this like 7, 11, 13, whose factors are just 1 in itself. And there are infinitely many, okay? Now, these are just some of the examples that you might encounter in our examples later. Now, let's go to our main goal, which is prime factorization. Let's start with our first example, 72. Now, we cannot right away rewrite a certain whole number, especially if it's quite big already, as a product of prime number. So, what we need to do is to do it bit by bit or in chunks. Now, think of two numbers first that when multiplied together, the answer is 72. Most probably, you're gonna think of 8 times 9. And that's correct. You may use other numbers like or other factors like 6 times 12. You will still end up with the same prime factors, okay? Because this is not yet the end. Since 8 and 9 are not yet prime numbers. So we need to rewrite still these factors as prime numbers. So 8 can be splitted as 4 times 2. That's what we know. While 9 can be splitted as 3 times 3. So let's just copy the multiplication symbol to maintain the operation between the numbers. And then among these 4, the only number which is not yet a prime number is just 4. So let's copy the rest times 2 times 3 times 3 and rewrite 4 as 2 times 2. Now, would you agree to say that these are now prime numbers? If yes, then this is already the prime factorization of 70. For our second example, let's have 187. Okay, the challenge in big numbers is, especially if it's not divisible by 2. It's easy to start with 2 or smaller numbers like 3, but in this case of 187, 2 and 3 both will not work. So what you can do, or what can I suggest, is try to use the small prime numbers that we know like 2, 3, 5, 7, 11, and 13 and so on, and see if one of these works. Now upon checking, 11 works. So this is not possible, and 11 works, and it can only be rewritten as 11 times 17. And since these are both prime numbers, so this is simply the prime factorization of our example. Nothing more, okay? For the third one, we have 336. Again, you can start with small numbers. Think of a number that when multiplied to 3 will give you 336. You can also use 2, but since the numbers are quite close to 3 or related to 3, then I used 3. So I did 3 times 112, and 112 can be splitted as 56 times 2. Now this is not yet the end because 56 is not yet a prime number, so we'll continue, copy the others, times 2, and rewrite 56 as 7 times 8. Now among these 4, we have 8, which is not yet a prime number, so again, let's continue, copy the rest, and rewrite 8 as 4 times 2. Then copy the other times 2. So make sure that you copied all the prime factors correctly and carefully, okay? And then last is, let's rewrite 4 as 2 times 2. So 3 times 7 times 2 times 2. And then copy the other 2's. And there you go. This is now the prime factorization of 336. Now down to our last example, we have 630. It's pretty easy because there's a 0, so you can use 10. So we can have 63 times 10. You can jump directly to 63 times 10. And 63 can be splitted as 7 times 9. And then copy times 10. Now, among these 3, 9 and 10 are not yet prime numbers. So let's rewrite both. 9 can be rewritten as 3 times 3, right? And 10 can be rewritten as 5 times 2. Now check, are all these prime numbers? If yes, then that's it. Okay, so that's it for our video. Thank you so much for watching.